if you read that question carefully, you'll notice it mentions 2 angles of depression. So stick figure lighthouse, we're going to assume the ocean is flat. And we've got our lighthouse at the very edge. That is the worst straight line I've ever drawn, but who cares? They tell us that that lighthouse is 145 feet tall, yes? Pretty sure I saw that correctly. And they tell us that, I draw this out a little bit, when the boat is at point A, and he looks down at the boat, that this angle here, angle of depression, is 10 degrees, which means the angle down here is also 10 degrees. Because remember, angle of depression, he looks out from wherever he's standing above the ground, has to tilt his head down that many degrees to see the landmark on the ground. Later, the boat is now at point B. To look down from the light tower to the boat at point B, this angle is now 68 degrees, which means this angle is 68 degrees. That is not drawn to scale. We don't care if it's to scale. We just need the picture on the paper. Yes. And the question after that is, what is it asking us to find? What is it asking us to find? Who can tell me? What did they ask us to find? It's in the word problem. Luna, what did they ask us to find? Last sentence, bruh. Point A to point B. Very good. Distance from point A to point B. So what I'm looking for ultimately is this distance here. My suggestion is we have 2 right triangles. We have a long, weird, skinny one with 10 degrees and 145. And then we have that same triangle, but now it's, and again, not to scale, 68 degrees, 145. If I can find this distance and this distance, what do I do with those distances to figure out from A to B? Your right will need tangent to find those numbers. What do I do with those answers to find that number? Subtract them. Good. So I'm going to give you a couple minutes, set up your tan fractions, calculate those distances D1, D2, find the distance from A to B. All right, I need a volunteer who can walk me through what to do. Do I have a volunteer? Y'all gonna make me get my name generator out, aren't you? You are. You are. Rude. Rude people. So rude. She's not here. I mean, she is here, but she's not like here. Ethan! All right, Ethan. I'm going to scoot you over a little bit. Can you give us the tan fraction for that first triangle? Tan of 10 degrees equals what? $145 over x. Good. Okay, how do we solve for x? Yeah, good. Multiply x from both sides. and then divide the tangent from both sides, which means we end up with what I saw in a lot of people's papers. This. Yes? I see some nodding. 8, was it 822, 823? 822.3? Very good. I can infer, since the only thing that changed from picture 1 to picture 2 is the degree, I can copy and paste and just substitute in 68 instead of 10. So I know that my next answer, if this is x and this is y, would be 144 over tan of 68. I hear a yep. What did we get? Was it exactly 59? 59.5. We agree? I hear yeah, but I don't want x and y. I want the difference between them. So the next thing I'm going to do is take those and subtract them. And when we subtract them, what do we get? 760 what? 762 rounded? 0.8. 763, very good. So the distance from A to B equals 763 feet. Yeah. Good. Good. So a note on word problems. We're noticing here our ability to solve real world problems partially involves our ability to interpret the information given into a picture on a paper. Because if I can't take the words I'm given and interpret them into a picture, it's harder to set up my right triangle and solve. So on your midterm, you will get like 90% of the credit for the problem as long as your trig matches your picture, even if your picture's wrong. So it's a little bit of a point deduction if you drew the wrong picture, but as long as everything that came after it is correct, it's all consistent, it all agrees, that's like 90%. That's still an A, right? So we need to focus on interpreting. But the big important part here is, can I take a picture and turn it into a trigonometry ratio and solve for an unknown? Good. Questions on our bell ringer? That zoomed out a little bit too far there. No questions? No. Okay. So let's go back to our slide deck here. Today, we are doing a short set of notes on how to convert between our two units of measure for angles. As in trig, we know we're all about angles. So how do I get between degrees and radians? You might want a calculator for this. So we are going to do some calculator math. I do not have a copy for you because I had a doctor's appointment during my prep period this morning, which means I did not get to make copies. So you have two choices. I'm going to give you about 90 seconds, 120 seconds, 2 minutes. You can either grab some paper and take this on paper. I will get out some graph paper. Or you can pull it up on your Chromebook. There is a PDF of Notes 2B attached to Google Classroom. You can import it to Kami and write on your Chromebook. Yeah? I'm going to give you about 2 minutes to choose. If you want to do it on paper, graph paper's up front. If it helps to make your decision, this was a really short set of notes. It's like a half page front and back. So yeah, graph paper is probably the easier route. no, you've missed a lot. We've missed you. It makes us sad when you're not here. I know. Whatever you guys were passing around, it hit me hard on Friday. I spent most of the weekend sick in bed, which sucks. All right. Let's get started. So, the whole idea for today is we've been playing with the unit circle since like week 1 of the semester, yeah, beginning of the course. We know what a full unit circle looks like. So, on the unit circle, if I make a single loop all the way around, how many degrees is that? 360, very good. If I start on the unit circle and I make a full loop all the way around, how many radians is that? 2 pi, very good. So, as mathematicians know, those two units must be equal. 360 radians measures exactly the same physical quantity that 2 pi radians does. So 360 degrees must be equal to 2 pi radians. You'll notice for that second line, to get from 2 pi radians equals 360 down to pi radians, what am I doing? From 2 pi to pi, what did I do? The answer, since nobody is awake today, is I divided by 2. Cut it in half, right? 2 pi is the full circle. Pi is the top half of the circle. It's half. What is half of 360? 180. Very good. We know 180 is a straight line. We know pi radians is a straight line. Very good. Focusing on the left, I want to go from pi to 1. What should I divide by? How do I turn a pi into 1? How do I turn anything into 1? Divide by itself. Yeah, anything divided by itself is 1. So on your calculator, what is 180 degrees divided by pi? Use the pi button, not the 3.14. We're in college trig now, no cheating. When I do it, I get approximately 57.3 degrees rounded. Like 57.29, something. I see nodding. Good. Good. Radians are a bigger unit of measure. It takes a whole lot of degrees to make up a single radian. So 1 radian is a little bit more than half of a quadrant in the coordinate plane, because half of a quadrant is 45 degrees. You can see in this circle here that we have 6 full and then 1 fraction, and that's coming from 2 pi. Pi is 3.14. 2 times 3.14 is 6 something. So it's about 6.3-ish radians for a circle, 2 pi radians per circle. The question for us is, how do I get back and forth between them? The reason that that is important is if I want to do calculations with angles and they're not inside a trig function, they need to be in radians. So I need to know how to get back and forth between those numbers. We're going to start with the reverse, which is what you guys were doing with the unit circle. How do I take radians and turn them into degrees, because we're used to degrees? How many of you have taken chemistry? One hand, two hands. Is anybody in chemistry now? Couple hands. You've learned about stoichiometry. I see a couple nodding. It's basically unit conversion. You're just matching up units. So I want to go from radians 2 degrees. If I want to cancel radians, I need to have radians in the bottom. I want my answer to be in degrees. I need degrees in the top. If I want to convert something that's in radians to degrees, I'm going to multiply by 180 over pi. Because the radians on top will cancel the radians on bottom. I'll be left with the degrees that are on top. We're going to do some examples together because practice is good. All right. Are we ready? Too bad. We're going to do it anyway. So first one says pi over 4, convert it to degrees. We take pi over 4. My direction says if I want to take that radians and turn it into degrees, I multiply by 180 over pi. What happens to those pi's? Yeah, we like that. That makes us happy. We grab a calculator. What is 180 divided by 4? I'm apparently faster than you. I got 45. That makes sense because we know pi over 4 is that halfway mark in quadrant 1, which should line up with 45 degrees. That's something we've seen in the unit circle. Now we're going to do ones that are a little less obvious. I'm going to give you a minute because I see pencils moving. Okay, next one. It says 3 pi over 5, convert from radians to degrees. Sylvia, what am I going to do? Multiply by 180 over pi. Very good. I don't know why I wrote an equal sign there. Come on, pen. There you go. What happens to the pi's? They cancel. That almost always happens because we almost always report radians as exact values with pi's in them. Yeah, good. So I need 3 times 180 divided by 5. And when you have an answer. Eunice has an answer. What'd you get? 108 degrees. Very good. Very good. That makes sense because I know 3 pi over 5 is bigger than pi over 2, which is the 90-degree marker, but it's smaller than pi, which is the 180 marker. So it should be somewhere between 90 and 180, and it is. Good. Knowing the unit circle can help. I'm going to give you about 90 seconds. I want you to do the same with numbers 3 and 4. I'm going to call on random volunteers to help. You're the first random volunteer because your name came up while you were out. If you make any, I'll pass, yes. All finished. Examples 3 and 4. Yeah. We got this. The pi will cancel out, the negative will carry through. All right, Ziza's going to do 3 for us. Oh, here. So Ziza got 330 degrees. Can I get a thumbs up? You also got 330. I see thumbs up around the room. Very good. Sorry, just so there's room for number 4. All right, good. Do we have a volunteer for number 4 before I pull out the random name generator? You're almost as bad as my 5th period. Okay. Frowny face. Frowny face. Allie, come on up. It's your lucky day. The fat side, yeah. Yes, but sometimes, oh. Yes, I'm sure. Thank you. So we have negative 60 degrees. Thumbs up if you agree. I see thumbs up around the room. Very good. The pi's cancel. The negative carries through. I know that negative should go clockwise around the unit circle from the positive x, so down instead of up, and pi over 3 should land me in that 4th quadrant, which is exactly where that is. Perfect. Very good. Question. If we know to get from radians to degrees, I multiply them by 180 over pi. What am I doing to get from degrees to radians? Pi over 180, yeah, because I need to undo what I just did. Multiply by pi over 180. You know that it's pi and 180. Whichever units you want in your answer, those are the units that go on top. Good. So I'm going to do 1 and 2, and then we're going to race to see who can do 3 and 4 faster. So number 1, 60 degrees. I take my fraction, I multiply it by pi over 180. Here is the unfun part. Generally, if I am converting to radians, I prefer that the answer has a pi and it has a fraction and not a decimal. Decimals are rounded. We don't want rounding error. So my job here is to reduce the 60 and the 180. I want something that divides evenly into both so I can cross cancel. And 60, good. They're both divisible by 60. So 60 goes into itself once. 60 goes into 180 3 times. Because 6 goes into 18 3 times. And if I look at what I'm left with a pi on top. 1 times pi is pi, and 1 times 3 is 3. So pi over 3. Which we could have predicted from example 4 in the last round, because we know negative pi over 3 and negative 60 correspond. So positive pi over 3 should correspond to positive 60. Good. Next one, the answer to life, the universe, and everything. We want to take 42 degrees, convert it to radians. Oh, and what am I going to do? Very good. Multiply it by pi over 180. The degrees, or the units I want, are in the top of that fraction. I'm going to put the first guy, my whole number, over 1. I'm going to cross cancel things that go into 180 and 42. So here's 6. 6 goes into 42 7 times, right? Yeah. And 6 goes into 180 30. Because 18 divided by 6 is 3, and then we have the 0 left over. So 7 pi over 30. If you are not sure that you reduced correctly, you can take the number parts, ignoring the pi, 42 over 180, and on your calculator do 42 divided by 180, and then go math frac, and it will convert it to a reduced fraction. So if you do that for 42 divided by 180, it gives you 7 over 30 on your calculator. So if finding the biggest divisor that goes into both is hard for you, use your calculator. Good. All right, take a second. I'm going to do them on the board. We'll see who's faster. Same process for 3 and 4. Vicky, for number 3, what did you get for your reduced fraction? 89 over 50? 60. Did I do that correctly? Yes, thank you. Sorry. I had a brain fart. Very good. Second one. Do I have a volunteer for the second one? What do we get for our reduced fraction? I have a vote from Luna for 14 over 45. Can I get a thumbs up if you agree with Luna? I agree with Luna. I also got 14 out of 45. Yeehaw? Okay. Of course it does. Okay. All right. Questions on how to convert between degrees and radians? No. So, a reminder, this is not on an equation sheet. This is something you have to know. One of the few things you have to know, right? I'm going to give you a unit circle, right? You're going to have your calculator. You have to know how to get back and forth. So pi and 180 are equal, whichever unit you want your answer in, that's what goes on top of your fraction. Good. Is there any more today? Is that it? I think that's it. Yeah. Yay. Perfect. Questions on the notes? Yes, you may. All right, you've got some time to work on some things. What's due today? Delta math. There were 2 assignments. One of them was optional. So we know week 3 Delta Math's due. What else is due? Extra credit. There was that assignment in Delta Math that's plus 5% to your midterm score if you have it completed. Those are both due today by 11:59 p.m. Yeah, so if they're not done, work on those. If they are done, you can start on your week 4. Reminder, we are on week 4. When is your midterm? Week 6. Right? We have an 18-week semester, so 6 and 12 are the 2 midterms, week 6. So it's coming up. Make sure you're keeping on top of your homework, keeping on top of your notes, coming to see me if you have questions. You've got the rest of the class period to work on your Delta Math. Yeah? Yay! Thank you.